Take note, key concept, factoring a sum or difference of cubes. First, a sum of cubes. A cubed plus b cubed can be written as the binomial a plus b times the trinomial a squared minus ab plus b squared. A difference of cubes. A cubed minus b cubed can be written as the binomial a minus b times the trinomial a squared plus ab plus b squared. You can sometimes apply the same techniques you use to factor quadratic polynomials to factoring a polynomial with a degree greater than 2. Take note, concept summary, polynomial factoring techniques. We'll see some techniques on the left and examples on the right. First, factoring out the greatest common factor. Factor out the greatest common factor of all the terms. An example, 15x to the fourth power minus 20x cubed plus 35x squared can be rewritten as 5x squared times the trinomial 3x squared minus 4x plus 7. Quadratic trinomials. For the trinomial ax squared plus bx plus c, find factors with product ac and sum b. An example, 6x squared plus 11x minus 10 can be rewritten as the product of two binomials, 3x minus 2 and 2x plus 5. Finally, factoring by grouping. Ax plus ay plus bx plus by can be rewritten as a times the binomial x plus y plus b times the same binomial x plus y. That can be rewritten as a plus b, the binomial, times the binomial x plus y. An example, x cubed plus 2x squared minus 3x minus 6 can be rewritten as x squared times the binomial x plus 2 plus negative 3 times the same binomial x plus 2, which can be rewritten as x squared minus 3 times the binomial x plus 2. Take note, concept summary, polynomial factoring techniques. Again, techniques on the left, examples on the right. Perfect square trinomials. A squared plus 2ab plus b squared equals the binomial a plus b squared. And a squared minus 2ab plus b squared equals the binomial a minus b squared. Examples. First, x squared plus 10x plus 25 equals the binomial x plus 5 squared. And next, x squared minus 10x plus 25 equals the binomial x minus 5 squared. Difference of squares. A squared minus b squared can be rewritten as the product of two binomials, a plus b and a minus b. An example, 4x squared minus 15 can be rewritten as the binomial 2x plus the square root of 15 times the binomial 2x minus the square root of 15. Sum or difference of cubes. A cubed plus b cubed can be rewritten as the binomial a plus b times the trinomial a squared minus ab plus b squared. And a cubed minus b cubed can be rewritten as the binomial a minus b times the trinomial a squared plus ab plus b squared. Examples. First, 8x cubed plus 1 can be rewritten as 2x plus 1 times the trinomial 4x squared minus 2x plus 1, and 8x cubed minus 1 can be rewritten as the binomial 2x minus 1 times the trinomial 4x squared plus 2x plus 1. In Chapter 4, you found the complex roots of quadratic equations. You can do the same with polynomial equations with degree greater than 2. Problem 2. Solving polynomial equations by factoring. What are the real or imaginary solutions of each polynomial equation? First, part A. X to the fourth power minus 3x squared equals 4. We'll start by rewriting the equation in the form p of x equals 0. The equation becomes x to the fourth minus 3x squared minus 4 equals 0. Then we can let a equal x squared. So we rewrite our equation temporarily as a squared minus 3a minus 4 equals 0. Now we can factor the expression on the left. A squared minus 3a minus 4 becomes the product of two binomials, a minus 4 and a plus 1, still set equal to 0. And now we replace a with x squared. Our binomials become x squared minus 4 and x squared plus 1, their product still equal to 0. And now we factor x squared minus 4 as a difference of squares. So x squared minus 4 becomes x plus 2 times x minus 2, and we still have the binomial x squared plus 1, all set equal to 0. It follows from the zero product property that x equals 2, x equals negative 2, or x squared equals negative 1. Solving that final equation, x squared equals negative 1, yields two imaginary roots, x equals I, or x equals negative I. And we can check our work. We can check by graphing the related function, y equals x to the fourth power minus 3x squared minus 4. The graph shown at the right shows zeros at x equals 2 and x equals negative 2. It also shows three turning points. This means that there are imaginary roots which do not appear on the graph. Part B. How about the equation x cubed equals 1? Again, our first step, rewrite this equation in the form p of x equals 0. So x cubed minus 1 equals 0. And now we'll factor this difference of cubes. X cubed minus 1 can be rewritten as the binomial x minus 1 times the trinomial x squared plus x plus 1. The product of these two is still set equal to 0. It follows from the zero product property that x equals 1 or x squared plus x plus 1 equals 0. We can use the quadratic formula to solve the equation x squared plus x plus 1 equals 0. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. This simplifies to negative 1 plus or minus the square root of negative 3 all over 2, which further simplifies to negative 1 plus or minus I times the square root of 3 all over 2. So we can now state the three solutions of x cubed equals 1 are 1, negative 1/2 plus I times the square root of 3 over 2, and negative 1/2 minus I times the square root of 3 over 2. Your turn, part A. What are the real or imaginary solutions of the polynomial equation x to the fourth equals 16? Part B. What are the real or imaginary solutions of the polynomial equation x cubed equals 8x minus 2x squared? Part C. What are the real or imaginary solutions of the polynomial equation x times the binomial x squared plus 8 equals 8 times the binomial x plus 1?